In this section, we are going to look inside the op-amp. But it is not the real internal circuit we are going to look at. We are going to look at a simplified behavioral model that behaves just like the op-amp. This behavioral model is also known as the ideal op-amp model. So, what is inside the op-amp? We have already presented the op-amp as a three-port device. There is the differential input, consisting of two input terminals. And the two input terminals are designated as the positive and negative input terminals of the op-amp. Then, there is a single-ended output terminal, where the amplified version of the voltage difference between the two input terminals are produced. Finally, there is the two power supply connections where the power comes from to produce an amplified version of the input signals are presented. We start with the schematic for the ideal op-amp. And this is the schematic for the ideal op-amp. It is a relatively simple circuit. And we shall delve into it in more detail in this section. It forms the basis for the rest of the development of a more complete behavioral model. Note that this model has two differential inputs, meaning that the input signal is the difference between two input terminals. And it has a single-ended output, meaning that the output signal is measured between the output terminal and ground. The first characteristic of the ideal op-amp is that the input currents are always zero. The next characteristic of the ideal op-amp is that the input differential voltage is zero. The third one of the group of input characteristics is the input impedance is infinite. This ties up with the first two, which states that the input current and differential voltage is zero. The first characteristics in the group of output characteristics of the op-amp is that the output impedance is zero. The second output characteristic is that the gain of the op-amp is infinite. Implicit in this ideal version of the op-amp is also the assumption that the bandwidth is infinite. The equation for the output voltage should be quite recognizable by now. It is the product of the gain and the voltage difference between the input terminals of the op-amp. If we assume that the gain is infinite, this means that the output voltage is infinite. This is clearly not realistic, so we should rather change the assumption from the gain being infinite to being very large. So, let's figure out how this model works. In this slide we are going to look in more depth at how the ideal op-amp works. The approach that we are going to follow is a different view of the same principle already presented earlier in this course. But this time, we incorporate more information by looking at how things work inside the ideal op-amp. Let's start with the schematic for the ideal op-amp. Again, notice that it has a differential input and a single-ended output. In this circuit the input signal is applied between the two input terminals. The positive terminal can be connected to ground, making it the same as the earlier circuits presented in this course. The input voltage is negative, as shown in the diagram. The output voltage is given by the now well-known gain equation. The gain equation is simplified, in the usual way, to obtain the expression for the output voltage for this circuit. In this case the output voltage is equal to the negative of the open loop gain multiplied by the differential input voltage. So, it is clear that just like before it is an inverting amplifier. Let's start with the schematic introduced in the previous slide. This is the schematic that we had in the previous slide. The input voltage is negative and the usual gain equation applies. And let's introduce the same circuit but with the input reversed. The polarity of the input is swapped around between these two circuits. The gain equation is simplified, in the usual as shown here. The end result is that the output voltage is equal to the differential input voltage, multiplied by the gain. We can see that it is still an inverting amplifier, just like in the previous slide. When the input voltage is negative, the output voltage is positive. When the input voltage is positive, the output voltage is negative. This is the end of section 5. The next section is about the transfer characteristics of the op-amp.